Find your notes.
I was so much talking about the woman that like sold houses. That one? Yeah, the old lady that was probably
Mostly just examples. Hey, chit chat's done.
Didn't we do this last year?
You could have.
Yeah, we definitely did a lot of this last
Yep.
year.
This section's total review. As we move on in this chapter, they're going to get a lot more challenging, and it'll be new to you.
Right.
I haven't even started talking. No.
I can't believe we have to do this.
There's nothing challenging today, so we will move on.
I really don't think we would have said there's nothing. My handwriting is so bad right now. That writing question. I was
Oh, toss it.
5 minutes. I was like, okay, this is
Oh,
gonna go really
or
Now you must be on that. I thought I had more time.
I didn't see it, like, I didn't go ahead and she's like 5 minutes.
I didn't go. I didn't shoot.
The writing portion.
I didn't go. My last 3 paragraphs, no, my last 2 paragraphs are awful.
The handwriting on my go back. She was about to puke.
Okay. So we're going to be flipping a quarter 3 times. I want you to be able to list out the sample space and answer those 4 probability questions. I don't think you would be able to answer those 4 probability questions without the tree diagram in front of you. Unless you're Mr. Wells, maybe you can.
Okay, well, no. What I thought, I didn't really like the notes with emphasis, so I actually did the top, so.
Oh. Well, so you didn't read very well. You're good at math, but you're not good at reading. Okay. All right. Are you ready? Not yet. Okay, I'll wait. We'll talk about the questions after we get the sample space written out. Yep. Okay. So when we are flipping a quarter 3 times, how many experiments are we doing? 3 experiments. Each time I flip the coin is a part of the experiment. So we're going to draw the tree diagram. What does the tree diagram start with? A dot first. Always the dot. Otherwise, I don't know how people manage to screw this up. If I start with a dot, now I do the first part of my experiment. How many possible outcomes are there? 2. Just the head or the tail. So I have those 2 branches coming off. Yes? We're not going there. I know. I'm not going there. Because that's not an equal chance of that happening. We don't want that. Well, what's the probability of that happening?
I don't know.
Exactly, I don't either. And I doubt Mr. Giroux knows. How many? If you flip a coin 1,000 times, how many times is it going to land on its edge?
It depends. Where are you flipping this? Like, are you by a big crack? Where's the
Okay.
cortical?
So we are going to assume
You have flat.
that the lands heads or tails. Okay, guys, you're kind of chatty today.
I'm gonna be chatty all
I know. Second part of the experiment. Here we go. Second part. Where do you draw the second part of the experiment? Off of each one of these, you do the second part of the experiment. And what are we going to do? Heads or tails. We're going to flip a coin. So I get heads or tails? Same thing here, heads or tails. So I see the two sets of branches, verticals. There's a set of branches. There's my first. Here's my second. I still got to do a third part of the experiment. Where does that grow from? Each one of these four things. Heads, tails, heads. Now list the sample space for me, please. Oh, somebody's having fun in school. They're having fun. That's not even right.
They're having a fun day.
Yeah.
I'm gonna go shut it down.
There will be no fun
Can we
in
go
school.
stream this for fun? Shut down.
Came out of Spanish room.
What?
I think I came out of the Spanish room. There's nobody next door.
I tried.
Yeah, that was my
Whoever did.
Okay, start listing.
1, 2. Now it's party bird. What? I never had to do this listing before. I didn't do it. It just makes everything messy.
You shouldn't be looking up. You should be able to figure this out on your own.
I never looked at these.
Right. Mine's just so slick.
Okay, when we're doing this theoretical probability, it's important that we know the total sample space. How many outcomes are in my sample space here? There are 8 different outcomes. So every single one of these probabilities is going to be out of 8, out of 8, out of 8. I don't even have to read them yet. I know they're all going to be out of 8 because that's my sample space.
I know these
Okay, what is the answer to the first one, Kayla?
3 out of 8,
Why 3 out of 8?
because there's only 3 where head occurs twice.
Exactly twice. Is she correct? I don't know. I wrote it down. Does head count? No.
Wait, why?
Why does head not count? Because there's 3 heads. This says exactly 2. What does exactly 2 mean to you? 2, no more, no less. So this one doesn't count. So there's 1 here. I would count this one, and that's it. Okay, that's right. Okay, the second one. The last 2 tosses were tails. Does that make sense to you now?
Yeah.
So how many of those are there? 2. This head, tail, tail, and the tail, tail, tail. So there are 2 out of 8.
Wait, what do you mean by the last 2 tosses?
What do I mean by the last 2 tosses? The last, I don't even know how to say that different. There's the first toss, there's the second toss, and there's a third toss.
The last
Okay. Last 2, so that'd be the second and third tosses were tails. Alright, it is 1/4. Okay. All 3 were the same. 2. You got head, 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 tail, tail, tail. Probability is really easy when you've got the sample space sitting in front of you. Had you not done this tree, I think these would have been very challenging. And then the last one, so you got a half, 50% chance. Because you're really only looking at 1 toss, and half the time it should come up with tail. Okay, you're good with that? The rolling 2 dice, people mess that one up all the time because they think there's 12 outcomes there. Mm-hmm.
Sorry, it's Friday. I don't know how to make the next
We're not going to list this completely. We're going to draw the tree, but we're not going to list everything out because I think you're going to be able to see it and then see it in your head when you need to do the probability question.
I just want to roll the 2 dice.
Okay, roll 2 dice and then answer these questions. The probability that you roll a sum of 7. A pair but the sum is less than 4. when you're ready. How many parts of the experiment are we doing here? When I'm rolling 2 dice. How many experiments is that? That's 2. I roll 1 die, then I roll another. Just because of the fact I roll them at once, that's still 2 experiments. 2 parts. So, start a tree diagram with a dot. Off of that comes the result of your first experiment. What can happen when I roll that die? 1, 2, 3, 4, 5, 6. So I'm going to have 6 branches coming off of this.
Oh my gosh, there's no way. Too little.
Okay. They're ugly. This one's kind of ugly. So then, off of each one of those, you do the second part of your experiment, which is how many off of each one? 1 through 6. Now, I don't want you to draw the whole thing out here, but I do want you to draw like the first one. Oh yeah, so it'd be lots. So you're not because you're going to have a visual of this in your brain, and you're going to know how many outcomes there are, and you're going to know the pairs without writing them all out. It's going to be okay. You're going to see when we come up here. You're going to be able to tell me what these are, even though I don't have them all listed here. Because your brains work pretty good with this stuff.
I don't know.
Well, let's just do the last one.
Let me just write 1 through 6.
You kind of want to have a picture of them. And then you got all these ones in here. Pretend they're all there. Yeah, sound effects are good. Help you remember. So this first outcome, like I said, we're not listing all of them. This would be rolling a 1 and then a 1. A 1 and a 2. A 1 and a 3. A 1 and a 4. 1 and a 5. 1 and a 6. Do I need to draw the second branch to know what's going to be here? 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. All the way down the last branch. 6 then a 1. 6 then a 2. 6 and 6. And you're going to know what's in between. How many are there going to be? Outcomes.
36.
There are 36 outcomes. 6, 6, 6, 6, 6, 36. So, every single probability that has 2 dice, I know my sample space is 36. Okay, are you ready for the tricky part? It's not even that tricky.
What is the tricky part?
Okay, it says rolling a sum of 7. Okay, guys, in the back, you really need to focus. Everybody. Sum of 7. Okay, think about the pairs that would be on this tree. Just start anywhere you want. Can you get a sum of 7 with a 1 first? We'll start there. 1 and 6. Anything in the 2s first? I would write these out. 2 and 5. Anything else going to give you a sum of 7? 3 and 4. Just work your way through the tree. Go to the 3s first. The 4s first. 4 and 3. Is that the same thing as 3 and 4? The outcome's the same, but that's a different spot on the tree. It happened here and it happened down here, so it's 2 different ways to get it. 5 and 2. 6 and 1. See how you can see the tree in your head on these and just work your way down the branches? So how many were there? 6 out of 36? A 1 in 6 chance. A pair. Rolling a pair. What are the outcomes where I roll a pair? 1, 1, 2, 2, 3, 3, 4, 4. Can you see the tree in your head?